Okay, here's a hypothesis test in context. An article in Journal reports that 34% of American fathers take no responsibility for child care. Research claims that the figure is higher for fathers in the town of Littleton. A random sample of 234 fathers from Littleton yielded 96 who did not help with child care. Test the researchers' claim at the 0.05 significance level. So we want to test the claim against an understood percentage of 34% that take no responsibility. So we're going to assume the null is that the proportion that take no responsibility is equal to 0.34. That would be the null. Oh, that's really sloppy. The researcher claims that the figure is higher. So the claim is that the proportion is greater than 0.34 in a specific town. We're going to look at a sample size of 234 adults, fathers from Littleton, and the rate of success of failing fathers, right, is 96 out of that 234. So we need to calculate that p proportion of 96 over 234. And we're going to test the claim at alpha. Alpha is 0.05. We can calculate the test statistic, make a sketch, and spit out the p-value. Now the calculator can actually do all of that for us if we run a hypothesis test in the calculator, which is nice. So we can do this is proportion, so 1 prop z test. When the null is 0.34, the x is 96, the n size is 234, and we're testing a proportion greater than, and I'm going to actually draw it on this calculator so we can see it. That'll me sketching my beautiful drawing. So the calculator will draw this distribution and give us the p-value. So this p in the answer is actually the p-value of 0.0116. So the p-value is 0.0116, and the test statistic was 2.27, about 2.27. If we look at that, that is suggesting that 2 over 2 and a quarter, almost 2 and a quarter standard deviations above that 0.34 relative to our sample. So the sketch would look like this. The only thing that's missing from this sketch is the critical area. All right, so the critical area is 0.05. Now we can compare the p-value to the critical significance level of 0.05 and see that the p-value is less than. So the p-value of 0.0116 is less than alpha. Since it's less than alpha, that means that this critical value is actually somewhere out here. We're buying this right here. So if that's true, then this is in the critical area. So the p-value is less than alpha, so we're going to reject. We're going to reject the null hypothesis.